Hello, welcome back to GSIM training. We will resume the training with the presentation on GSIM concept group. Catrin and Mikko, are you there?
Yes.
Yes. Okay, so concept group, as its name suggests, is a group of concepts that are quite familiar and frequently used by many statistical organizations. And as Jenny said that in the introduction, people can start with the different GSIM groups, like green groups, blue groups, and so on. And yeah, we don't need to use all the groups all at the same time. And I heard that many organizations that use GSIM often start with this concept group because of this. And GSIM in total has about 130 information objects, and the concept group has the largest number of information objects in the GSIM model. So these are the reasons why we have 40 minutes for this group. And the concept group will be presented by Catrin Karling from Statistics Sweden and Mikko Saloila from Statistics Finland. Catrin is a business architect working on adapting GSIM to Swedish context, and Mikko is a senior statistician in Standards and Method Department at Statistics Finland. He is also part of a team implementing GSIM into a new metadata system at Statistics Finland. So Catrin and Mikko, please start when you're ready.
My name is Catrin Karling and I'm a business architect at Statistics Sweden. This presentation will guide you through the concept group, and it's divided into two parts. I will begin with the variable, value domain, and population, and after around 15 minutes I will pass you over to our Finnish colleague Mikko Saloila, who is going to talk you through the classifications. The concept group is used to define the meaning of data, providing an understanding of what the data are measuring. It contains mainly traditional metadata, such as variables, code list classifications, and the important objects are instance variable, value domain, variable, unit type, and statistical classification. And we will go through all of these in details in this presentation. In total, there are 39 information objects in the concept group. First of all, we will look at the variables, and then the value domain, the population, and later Mikko will tell you about the statistical classifications. This picture describes the variable and the information connected to it in the concept group. The variable measures a unit type. Examples of variables could be the height of a person, the age of a person, color of vehicles, and they measure or say something about a unit type. A unit type could be the person, vehicles, households, horses, or anything that you want to measure. That's the unit type. A represented variable takes the meaning from the variable. That means, and the value domain measures the represented variable. This means that the represented variable is a combination of a variable and a value domain. Sometimes the variable is the same, but the value domain could be different. You can measure the same variable, but using different value domains. The variable is use of a concept as a characteristic of a population intended to be measured. And the variable combines the meaning of a concept with a unit type to define the characteristic that is to be measured. And the examples they have in the GSIM is sex of person, number of employees, and value of production. Other examples of variables is age of person, color of vehicles. And a concept can be used for different unit types. You could use the concept age for persons, horses, dogs, or something else. And every time you connect a concept to a unit type, it becomes a variable. And a unit type is a class of objects of interest. And this is the description in GSIM. It says that a unit type is used to describe a class or group of units based on a single characteristic, but with no specification of time and geography. For example, the unit type of person groups together a set of units based on the characteristic that they are persons. And it concerns not only unit types used in dissemination, but anywhere in the statistical process. E.g., using administrative data might involve the use of a fiscal unit. The unit type groups the real world into groups to make it easier to use it for statistical purposes. We could be interested in to know something about households, persons, enterprises, vehicles. And we try to group these units to make it easier to compare and measure. And the unit type is important, of course, when you collect the data as well as when you disseminate it. And it could be the same unit type throughout in all phases, but it could also be different when you collect something and you disseminate something else. At Statistics Sweden, we have around 20 to 25 unit types, and these were defined more than 10 years ago. And it has been enough for describing our observation registers. When we now start using GSIM for the whole statistical process, that number could be changed. Probably we need some more unit types, but our strategy is to be very careful when adding new unit types. This is an example from Statistics Norway. The name of the variable is total income, and the definition is the sum of income from work, property income, taxable transfers, and tax-free transfers received during a calendar year. And the unit type is person. The variable measures the income for the unit type person. And if we put this information into the information objects, the variable that we saw on the previous page would be total income with the definition, and the unit type is person. And now we can use the represented variable to define the variable further by adding a value domain. The represented variable takes the meaning from the variable, and we use a value domain to measure it. Total income can be measured in different ways, and that will be described in the value domain. This shows the value domain, and the value domain is a set of permissible values for a variable. And the values can be described by enumeration or by an expression. The value domain is always, it's a type, it's either enumerated or described. A value domain expressed as a list of categories and codes, like the example, male, M is male and F is female and O is other, is an enumerated value domain. And Mikko will tell you more about enumerated value domains later. A described value domain is a value domain defined by an expression. It could be all real numbers between 0 and 1. It could be the length, height, weight, temperatures, number of vehicles. And the value domain can be used for different variables. When defining a represented variable, you can also if you have temperature, you can also say it's in Celsius or Fahrenheit. So you can always specify it further. It's described value domain. A represented variable is a combination of a characteristic of a population to be measured and how that measure will be represented. It's a combination of a variable and a value domain, and that will create a represented variable. There are some examples in the GSIM. The pair number of employees, integer, where the number of employees is the characteristic of a population, that's the variable, and the integer is how that measure will be represented. And if the variable is industry and the substantive value domain is level 1 of NACE 2007, the pair is industry NACE 2007 level 1. And the last one, the represented variable sex of person, 1 to 3. The variable is sex of person. We saw that earlier. And the representation is 1 means male, 2 female, and 3 is other. I can pick a value domain and a variable and combine them, and that will be a represented variable. This is another example from Statistics Norway. This is a represented variable. The variable is country of birth. And the definition is this variable refers to country where a person was born. That is the mother's country of residence at the time of birth. The unit type is person. The value domain is the classification of country and citizenship in population statistics. You have the variable and you have added a value domain. This is another example, continuing on this total income that we saw on the first page of Statistics Norway's. The total income is a variable and it measures the unit type person. The value domain is all real numbers and the represented variable is a total income. The represented variable is the combination of a variable and a value domain. Now we come to the instance variable. The instance variable takes the meaning from the represented variable. And the instance variable measures a population. And the population contains units. A population is more specific than a unit type. It describes more exactly what you are measuring. If the unit type is person, the population could be persons in Finland 1st of January 1970. And the population includes time and geographic boundaries. And the population contains units, and the units are for the population persons in Finland in 1st of January 1970. It could be Hans, Eva, and Johan if they were persons in Finland. This is information from GSIM. An instance variable is the use of a represented variable within a data set. It may include the information about the source of data, meaning where the data came from. And the instance variable is used to describe actual instances of data that have been collected. And there are some examples in GSIM. 2 examples. Gender, Dan Gilman has gender male, Arfan Gregory has gender male, etc. And then you have a unit and you have the value for that person. Number of employees, Microsoft has 90,000 employees and IBM has 433. This is the population information. A population is the total membership of a defined class of people. objects or events. A population is used to describe the total membership of a group of people, objects, or events based on their characteristics, e.g. time and geographic boundaries. The examples here are adult persons in the US on 13th November 1956, and computer companies in the US at the end of 2012, and universities in the US 1st of January 2011. And a population is used for describing what data measures, if it's all persons in Sweden or if it's only those with a university degree or a certain age or something. Person is still the unit type, but the population explaining in detail what data are measuring. One of the popular unit types in Sweden for the observation registers, as we have documented today, is persons. And we have more than 100 population defined using the unit type person, and then you have population describing exactly what population you are measuring. A unit is the object of interest in the business process. And there are 3 examples in GSIM. The units are the individuals in Arafan Gregory, Dan Tillman, Barack Obama, etc. And for computer companies, that population, it would be Microsoft, Apple, IBM, etc. And for the university, it would be Johns Hopkins, University of Maryland, Yale, etc. The unit is one entity in population. It could be companies or persons for these examples we had before. And if I put in the instance variable, this is just an example. The represented variable is number of employees. And the instance variable is that Microsoft has 90,000 employees. So it measures the population, and a population contains a unit Microsoft. The last picture shows all information objects we looked at. A unit type is enterprises, computer companies is the population, and Microsoft is a unit in the population. The variable measures enterprises. In this specific case, its integer is used as the value domain. And the instance variable is that Microsoft has 90,000 employees. When the data has been collected, we have the value for Microsoft. Right, now I will hand over to Mikko. I think he is the one going through the rest of the concept group.
Yes, thank you, Catrin. Can you hear my voice? Yes. Good. So next I'm going to tell you a bit of information about the classification information objects, and those include the enumerated value domain, the statistical classification, level, classification item, code, category, correspondence table, and map. So here's the enumerated value domain. It's a type of value domain, like Catrin told just recently, and it takes value from a code list or a statistical classification. And next I'm going to tell you a little bit about these 3 information objects: the enumerated value domain, code list, and the statistical classification. A value domain expressed as a list of categories and associated codes. That's an enumerated value domain. So an example would be M for male, F for female, 0 for other, but you could also use different kind of codes on those ones. Code lists. It's a list of categories where each category has a predefined code assigned to it. The explanatory text is that it's a kind of node set for which the category contained each node has a code assigned as a designation. This is something of information model centric language. So if you look at the information model itself, it goes through these kinds of objects, and I have those also in other pictures, but you don't have to care too much about the nodes and node sets. Those are information modeling stuff. The important stuff is that in a code list you have, for instance, 1 male, 2 female, and similar code lists can be grouped together via the relates to relationship in the model. And here's the statistical classification, and there's a lot of text. I won't read it, but the main thing in statistical classification is that in a standard statistical classification, the categories at each level of the classification structure must be mutually exclusive and jointly exhaustive of all objects or units in the population of interest. And that means that this is a sort of a difference between code list and statistical classification, that you have a certain quality stamp in a statistical classification that says that it conforms to this rule, and the code list might conform to it or not, so it doesn't have to. So there's a bit of a difference between these information objects. But for people who don't really are that familiar with statistical classifications, might be a bit confused, because from the information model perspective, they look quite similar. But statistical classification may have a flat linear structure, or it might be hierarchically structured, such that our categories at lower levels are subcategories and so on. So there's a lot of structures involved in this as well. We see a little bit more about the structure of a classification. So in the top, we have a classification series, and it groups statistical classifications. Then statistical classifications has levels. Either it has just one level, so it's a flat one, or it has several levels, so it's a hierarchical one. And the levels group classification items. Those classification items then contain code and a category. Then correspondence table compares statistical classifications, and it contains mappings, which means a map information objects of classification items. I have an example of this which will make it a bit clearer. First I had the description. So classification series is an ensemble of one or more statistical classifications. So it just groups statistical classifications together. And the level, like I said, is an object that creates structure inside a statistical classification. So it means that it either has one level or several levels, and that's important in a standard classifications where you usually have a lot of levels describing the actual thing. And the classification item is the fact that actually represents a category at a certain level within a statistical classification. It defines the content and the borders of the category. So a unit can be classified to one and only one item at each level of the classification item contains the code and the category. The correspondence table, it expresses the relationship between two statistical classifications. This is very important when you have different versions. If you have a new version of a classifications, let's say from year 2015, you have one version, and then 2010 was the earlier one, then you have a correspondence table between these two classifications. And it makes it a lot more easier to compare these two classifications over time, which means to actually compare the data of this. A map is the actual thing that is mapping the two classification items together. So if you have a source classifications, like in my example, the 2010 classification, and then you have the 2015 classification, then you have a map between those two classification items that tell that which classifications items are linked together in the new version and old version. So here are the examples. I think these will make it a lot more clearer. So in in the same picture where you have a classification series, it might be a standard industrial classification in this example. And then the actual classification would be the standard industrial classification 2008. There are several levels. In this examples, I've chosen the level 3. And then there's the classification item 022 logging. And the classification item combines the code 022 and the category, which is logging. Then the correspondence table could be, for instance, between standard industrial classifications 2008 and 2002. And it would include or contain mappings. And one map could be 020 forestry logging and related service activities, which corresponds to this 022 logging. So the general idea is that you have the classification structure here in the left, and then you have the correspondence things in the right. And there's also some text about nodes. Like I said before, those are information objects in GSIM, and they are mainly information object, sort of information modeling things. So this is just a simplified view how you would represent your classifications in GSIM. But they do go through these kind of information objects when you go into the click. That's just not to get confused when you compare this picture to the one on the GSIM clickable. I have a more concrete example from our classification database, where we have statistical classification, the standard industry classification. It has several levels, and in this case, they are represented by a letter, and the levels are, one level is the letter, for instance, A, agriculture, forestry, and fishing. Then in the second level, we have this classification item, which then combines the code 05 and the category mining of coal and lignite, and together they are the classification item. So this is the simple way to actually represent these GSIM information objects in the real world and in the classification web page in this example. Here is a way to physically represent the correspondence table. So here we have a picture of our website where we have a correspondence table between the statistical, the standard industrial classification 2002 and 2008, and then we have on the left we have the 2002 version, and then on the right we have the 2008 version. And then if you take one segment out of it, you form a map of 01 agriculture, hunting, and related service activities, and then you map 01 crop and animal production, hunting, and related service activities, forestry and logging, and services to buildings and landscape activities. And the map combines these two classification items from different classifications into one map, which makes it a lot more easier to compare these classifications over time. So this is really important stuff for researchers and for customers wanting to know how things have changed over time, also for statisticians. Yeah, and the next slide, I think it was final slide. So more information about concept group can be found under that link that will bring you into Clickable. There's 39 information objects altogether in GSIM version 1.2. So this was only roughly half of it in mine and Catrin's presentation. So a lot more to explore over there.